we're going to be learning about best fit equations. But first we need to refresh our memory about what each of these functions look like. So we're going to be looking at scatter plots, which are just basically a bunch of dots. So if it's linear, they're kind of going to be grouped together in a shape that generally looks like a line. For a quadratic, they're going to kind of make a U shape. And it could be upside down the other way. Exponential, it's going to start off slow and then grow, something like that. And cubics, going to make our sort of up and down S shape. So for these equations, we're going to use the Desmos calculator. So the first thing we're going to do is we're going to go to desmos.com. So desmos.com. We're going to start graphing. So here we have our blank graph space, and we're just going to add a table. So in our steps, we're going to click the plus sign and choose table. And we're going to put our data in that table, and then the dots will automatically show up on the graph, which I'll show you in just a minute with our example. And then we're going to determine the type of graph. So which one of these four does it look like? On Desmos, in line 2, we're going to type the general form of the equation that we pick, and I'll show you what those are in just a minute. And then finally, we're going to write our equation. So let's look at our example. A diamond merchant has determined the values of several white diamonds that have different weights, which are measured in carats, but are similar in quality. The chart below shows each diamond's weight and its value in thousands of dollars. So here's the weights and here's the values. So we're going to determine which regression to use. We're going to write the equation, and then we're going to use that equation to solve some questions. So let's go back to Desmos. I'll make this a little bit smaller so I can see my chart at the same time. So in X1, I'm going to put all the weight values. So 0.50, 0.75, 1.0, 1.25, 1.5, 1.75, 2.0, 2.75, and 3.5. So see, they're all there. Then I'm also going to put in the values for each one in my Y1. So 4.6, 5.0, 5.3, 5.8, 6.7, 7.3, 7.9, 10.7, and 14.5. So there's my scatter plot. Now, it's kind of hard to tell which type it is because we have so much blank space. So what I'm going to do is I'm going to look at my x values. They go from 0.5 to 3.5. So I'm going to click on the little wrench here in graph settings. And my x's basically go from 0 to 4. So I'm going to change this to go from 0 to 4. My y values go from just above 4 to just under 15. So I'm going to change this from 4 to 15. Now if I re-click this, feel like that I feel like that gives me a little bit better um, visual of what this is doing. Now, some people would say this is linear because the first ones do look kind of linear. But if it kept going linear, these two dots should be down over here a little bit more. If you notice, this is starting off slow and then it's starting to curve up like our exponential graph. So our exponential is going to go in line 2. And we're going to do y, and then we need a sub 1, a subscript. So I'm going to hit this. There's an ABC button down here that it's hard to see. Sub 1. And then we need to do approximately, which is the squiggle, A times B. Then we want the exponent of x sub 1. Now you see if I close my keyboard, you can see that we have this curve that basically goes through pretty close to all our dots, which is great. So it tells us down here that A is this value and B is this value. So that's going to help us write our equation. So we determined that we would use an exponential regression. Regression and best fit mean the same thing. So our equation, we're going to follow the form that we had here that we typed into Desmos. So y, you're not going to use the sub 1 and you're going to put equals. We're going to put our a value. And 2 decimal places is enough, 3.65. And then instead of the dot for times, because it can get confusing with the decimals, I'm going to use parentheses. Then I'm going to put my b value, 1.48, parentheses, to the x power. Because remember, when it's exponential, the x is the exponent. So now, determine the value of a 2.5 carat diamond. Carat is the key word here. I'm going to look for carat back up here. What was measured in carats? The weights were. And our weight was our x values. So that means that 2.5 is our x value. So I'm going to plug that into my equation. Y equals 3.65 times 1.48 to the 2.5 power. Since our variable's on the other side of the equation and this is all together, we can just type it in our calculator and we get that y equals 9.73. And what was our units for value? It was thousands of dollars. $1,000. And our final question, approximately how many carats is in a diamond valued at $7,000? So it tells us right here that it's giving us value, which was our y. So we're going to have to plug in 7,000 for our y. But let's look up at our chart. These numbers don't quite look like this one does. So let's think about this. The value was thousands of dollars. So this was $4.6 thousand, $5,000, $5.3 thousand. So since this is $7,000, our y value is 7 because of the units we had. So we're going to plug that in for y. 7 equals 3.65 times 1.48 to the x power. Now, the nice thing about this is I can use Desmos to help me here as well. So I'm going to close out what we had because we don't need those anymore. and I'm going to go to my first equation. So the first side of the equation was 7. So I'm going to put that in the first line. I might have to zoom out a little bit so we can see it. Oh, sorry. We're going to put y equals 7. And there's that red line there. And then we're going to put our equation that we got from the regression calculator. So right here. So y equals 3.65 parentheses 1.48 close our parentheses to the x power. And what we're looking for is where they intersect, and it actually already showed us that's 1.661 is our x value. So that means x equals 1.661 carats, because that's how we were measuring our x values. So one last thing that I want you to write in your summary is the general equations that you need for Desmos. So if it's linear, you would type y1 is approximately mx sub 1 plus b. For quadratic, it'll be y sub 1 is approximately ax 1 squared plus bx sub 1 plus c. Cubic, this one's a long one, y sub 1 is approximately ax sub 1 cubed plus bx sub 1 squared plus cx sub 1 plus d. And finally, our exponential, which you already saw was y sub 1 is approximately a times b to the x sub 1 power. That's all for today. I'll see you in class.